Alright, so for the past couple of weeks we've been working on expressions and we have been simplifying expressions, and we did that first because now we're going to start working on equations. And for this week, the week before Thanksgiving, we're going to start working on equations, and we're going to do a couple of days where we work with manipulatives, and then a couple of days where we have a notebook entry and we work with just numbers. And then when we come back from Thanksgiving, we'll start doing, we'll review for a day or two, and we'll start doing multi-step equations. So for this week, we're going to start with simple equations so we can get used to solving those equations. And then, like I said, when we come back from Thanksgiving, we'll start working on more complex equations. So it does get harder, so just bear with me for this week. We'll do these couple of days of manipulatives, and then we'll move on. So the first thing we need to do is go over a little vocabulary. So we've been working on expressions, and we know that expressions have no equal sign, and they can be simplified but not solved. So simplifying is where we have combined our like terms and got them down to the most simple we could get them. So this week we're going to start on equations. An equation does have an equal sign, and it can be solved. So we will be solving for whatever our variable is. Again, a variable is the letter. It could be X, it could be Y, it could be A, B. Any letter that you can come up with can be a variable, and we can solve for it. Inverse operation is the opposite operation. So the inverse of adding would be subtracting. The inverse of multiplying would be dividing, and so on. And back to that additive inverse that we learned about at the beginning of the year, which is adding the opposite. Additive inverse. Inverse means opposite. We add the opposite number, which equals 0. For example, a positive 2 plus a negative 2 equals 0. So we're going to need manipulatives. You'll need your chips, or your counters as we called them, our red and yellow counters. If you are in my class, I'm giving you some little Dixie cups. If you are at home and you don't have any Dixie cups, you can just draw squares for your variable. That's fine. Anything you can do to just represent your variable. So our Dixie cups are going to represent our variables. And then, of course, we have our red and yellow counters, just like we've been working with. And our reds are our negatives, and our yellows are our positives. So let's get started. So let's say we have an equation that says 2x plus 6 equals 10. And remember when we did this in the beginning, when we were learning how to add integers, we did this and we drew a line where our equal sign would be. So now we're going to represent our problem. So we have our problem, and we're going to represent it with manipulatives. So I have 2x, so I'm going to use 2 of my cups. 1, 2. And I have positive 6. So I'm going to put positive 6. 2, 4, 6. And it's equal to positive 10. So I have to put 10 over here. 2, 4, 6, 8, 10. Okay, remember the first thing we need to do is check our model. I have two variables, 2x. I have 2, 4, 6, positive 6. And I have 2, 4, 6, 8, 10, positive 10. So my model is correct. So we need to get this variable by itself. It is a loner. It wants to be by itself. So we need to get all of this to this side. So how do we do that? Well, the first thing we can do is get this positive 6 to the other side. But we have to do the additive inverse of positive 6 to get it to the other side. So whatever you do to this side, you have to do to this side. So if I'm going to do the additive inverse to positive 6, then I need negative 6. So 2, 4, 6. Whatever I do to this side, I have to do to this side. So I have 2, 4, 6. Okay, so we know how that additive inverse works. A yellow and a red make a negative. So I have positive 6 and negative 6. So I have a match to each of these, so they completely go away. They go away and I'm left with 2x. This goes away is equal to 10, and I have my additive inverse of 6 over here. So I have to take those away. 1, 2, 3, 4, 5, 6. So now I am left with 2x is equal to 4. So I still need to get my 2 by itself. So what I'm going to do now is I'm going to divide these 4 counters into these 2 cups. So I have to do it one at a time because I need them to be equal. 1, 2. 1, 2. Now I need to get this x by itself. So I don't need to know how many are in 2 cups. I only need to know how many are in 1 cup. So when I dump this out, they were positive. I have 2 yellows. So 2x plus 6 equals 10. X is equal to 2. So in other words, if I go back and I substitute 2 for x, because now I know that x is equal to 2. So if I said 2, and I know that x is equal to 2, 2 times 2 plus 6. 2 times 2 is 4, and 4 plus 6 is 10. Then I know that my answer is correct. Bear with me. Don't freak out yet because we just started. So I'm going to do another one as like an example, and then we'll try together. Okay? Let me erase this. Okay, let's try another one. So let's have 3a minus 4 equals 8. So the first thing we're going to do is model our variable. It's 3a, so I'm going to do 3 cups. Or if you're at home, you'll draw 3 squares. 1, 2, 3. Negative 4 would be 4 reds. 1, 2, 3, 4. And positive 8. 1, 2, 3, 4, 5, 6, 7, 8. So now we have 3a minus 4 equals positive 8. So the first thing I need to do is I know that my variable wants to be alone. So we've got to get rid of as much as we can. So I have negative 4, so in order to get rid of it, I can do an additive inverse, which would be positive 4. And if I do positive 4 here, then that means I also have to do positive 4 here. Okay, so now I can get rid of my additive inverses, which equals 0. So I can get rid of these. And now I'm left with 3a equals 12, positive 12. So how do I get my variable by itself? I'm going to divide these chips into these 3 cups. And I need to do it one at a time so I make sure I have equal groups. So 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. So now I need to know how many are in 1. So now I have, and we know that they're positive because we put them in there as yellows. So they're positive. So A is equal to positive 4. If A is equal to positive 4, that means we can put it back in our equation. So 3 times 4 minus 4 equals 8. Let's see if that works out. So 3 times 4 is 12, and 12 minus 4 does equal 8. So our equation is correct. Let's try another one. This time I'm going to write one out, and I want you to try to model it. So this time let's do 5f minus 3 equals 7. So pause the video and see if you can model it. Okay, so I hope you paused the video and you modeled it. So I see that I need to model my variable. It is 5f, so I would need 5 cups. Or 5 squares if you're at home. 5 cups. Okay, I see I need to model -3, so that would be 3 reds. 2, 3. And positive 7. 1, 2, 3, 4, 5, 6, 7. Okay, so remember your variable needs to be by itself. So in order to get rid of this 3, we need to do the additive inverse, which is positive 3. So 1, 2, 3. And whatever we do to this side, we also have to do to this side. 1, 2, 3. Remember, I had to add 3 positives to this side. Now I can get rid of my additive inverses. And there are no additive inverses on this side because they're all yellow. So now in order to get my f by itself, I have to divide these into these 5 cups, one at a time. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So now I want to see how many is in 1 cup because I need to know how much 1F is. And 1F is positive 2. So let's put that back in our equation and see if that works. 5 times 2, because F equals 2, minus 3 equals 7. And let's see if that works out. 5 times 2 is 10, and 10 minus 3 does equal 7. So 7 is equal to 7. So we are correct. Okay, let's try another one. This time let's try 4G plus 2 equals 14. Okay, pause the video and try to model that. All right, I hope you paused your video. Let's model it. We have 4G, so we have 1, 2, 3, 4, plus 2, which is a positive 2, 1, 2, and positive 14. 2, 4, 6, 8, 10, 12, 14. So I have positive 14. 2, 4, 6, 8, 10, 12, 14. Okay, 4G, so I have 4 cups, positive 2, positive 14. So in order to get our G by itself, we have to get rid of this 2 first. So in order to get rid of that 2, we do the additive inverse, which would be negative 2. And if we do it to this side, we have to do it to this side. Negative 2. Now we can remove our additive inverses. Get rid of these. And we also have additive inverses on this side this time, so we get rid of those. Now we are left with 4G is equal to 2, 4, 6, 8, 10, 12. So now we have to divide these 12 into these 4 cups one at a time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And remember, we want to know how much 1G is. So 1G is positive 3. We know you need to make a note of what color it is when you put it in case they flip over. So if 1G is equal to positive 3, does that work out? So if G equals 3, then 4 times 3 plus 2 should equal 14. Let's see if that works. 4 times 3 is 12, and 12 plus 2 does equal 14. So that means that our equation is correct. Okay, I'm going to give you one more to model, and we'll model it together. And then I'm going to give you a few problems for you to write down on your paper and try and practice with your cups and chips. And then tomorrow we'll do some more of this, and you'll have an assignment that you'll turn in tomorrow, but no assignment to turn in today. Today's just our practice day. Okay, this time let's try 8s plus 6 equals negative 10. So, pause it and see if you can model it. Okay, so we need to model 8s, which means we'll need 8 cups, or 8 squares if you're at home. So we have 8 cups. We need positive 6. And we need negative 10. 2, 4, 6, 8, 10. Remember to make sure your colors are correct. If your colors aren't correct, it will not work out. So if it's negative, it has to be red. If it's positive, it has to be 6. So I modeled 8s plus 6 equals negative 10. So I want to get my s by itself. So in order to do that, I need to get rid of this positive 6. And to do that, I need to do the additive inverse, which is negative 6. And don't forget, if you do it to this side, you have to do it to this side. Okay, so now we can get rid of our additive inverses. So we'll get rid of it here. I don't have any here, so I'll leave that alone. So now I'm left with 8s is equal to negative 2, 4, 6, 8, 10, 12, 14, 16. So I need to divide these negative 16 into this 8 cups. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We know that our answer is negative, and we only need to know how many is in 1 cup. So it is negative 2. So that means that 1s, or s, is equal to negative 2. So let's put that into our equation and see if it works. So 8 times negative 2 plus 6. 8 times negative 2 is negative 16 plus 6. So negative 16 plus 6, my signs are different, so I subtract, and I would get negative 10. So negative 2 is what s is equal to. Okay, I'm going to give you a few for you to practice modeling yourself. And remember, you don't have anything to turn in today, but you will have something to turn in tomorrow. So make sure you practice, and you practice well. Okay, here's 3 problems for you to practice. 7x minus 2 equals 12. 5y minus 10 equals 5. And 4x minus 2 equals negative 10. Make sure that you're modeling that with your manipulatives. And we'll do this some more tomorrow. Good luck. And I hope you have a great day.